So the structure of atom. We had done this structure of atom. So in the structure of atom, we had studied about the discovery of electrons. So what is the other name for the discovery of electrons? Which rays? What were the name of the rays which were discovered during the discovery of electrons? Abhinav? What was the other name? What type of rays were discovered during the discovery of electrons? Was there any specific name given to them? Neha? Yeah, Neha, was there any specific name given to them?
Sir, can you repeat the question?
For the discovery of electrons, there were some type of rays which were discovered. What was the name given to those rays?
Sir, it was positively charged rays, yeah.
During the discovery of electrons?
Sir, the rays.
Alpha rays?
No, they were not the alpha rays.
Sir, those are positively charged rays. Yeah.
No.
Gamma rays?
They were negatively charged rays and they were called cathode rays. They were called cathode rays.
Sir, it was positively charged rays, yeah. Not negative.
They were negatively charged. The rays were negatively charged, which were called as cathode rays. And they were called as the cathode rays as all the rays they originated from the cathode. The negative electrode was also called as the cathode. Okay. Okay. So what was the charge? What was the mass of those particles? What was the mass of those particles?
So could you repeat the question again?
Harini, are you there?
Yes.
Siddharth? Okay, Siddharth.
Yes, sir.
So what was my first question was that what was the name of the rays which were discovered during the discovery of electrons? So during the discovery of electrons, there were certain particles which were discovered, and those rays, the particles constituted a ray. What was the name given to those rays?
Canal rays.
No, they were called as the cathode rays, not the canal rays. Canal rays were discovered during the discovery of protons or during the discovery of positive charge. Okay. So positively charged particles or protons, they were discovered. So positively charged particles or protons, they were discovered and they were known as the canal rays. Right. So there was a difference between canal rays and cathode rays. What was the difference between canal rays and the cathode rays? Aman, what was the difference between canal rays and cathode rays?
Sir, canal rays is positive and cathode rays is negative.
Okay, canal rays were positive and cathode rays were negative. Which had a greater mass? Canal rays or cathode rays?
Sir, canal rays.
Canal rays had a greater mass and they were about 1,000 times heavier than those of cathode ray particles, okay, which were called as the electrons. So electrons were lighter than the protons. If you see the mass, so the mass of electrons is less than the mass, it's about 1,000 times lesser than that of the protons. Okay. So next question is Orosmith. Yeah, Orosmith.
Yes.
Okay. So Orosmith, what is the name of who discovered protons? Who discovered protons or positively charged particles?
Rutherford.
Rutherford. No. Prince. Who
Yes, sir.
discovered? Who
Sir,
discovered
E. Goldstein.
E. Goldstein. It was Goldstein who discovered about the protons. Okay. So E. Goldstein discovered about the protons. Then what was the name of the J.J. Thomson's model? Anyone who knows the answer can speak up. Unmute yourself and speak up. So
Sir, plum
Siddharth,
pudding.
From cake, sir.
Plum pudding
okay,
one.
plum pudding model. So up to now, just we did about discovery of electron. So the discovery of electron, it was carried out by J.J. Thomson. And here the rays were called as the cathode rays. The rays were called as cathode rays. And all the electrons, which type of charge is carried by the electrons?
Negative.
Negative charges. So negative charges, they are carried out by the electrons. Then after this, we discovered canal rays. And who discovered the canal rays? Siddharth, who discovered canal rays?
Goldstein.
Goldstein. It was E. Goldstein who discovered canal rays. And which type of particles were they? What charge do they bear?
Positive.
Positive charge. So canal rays, they bear positive charge and they were called as the protons. Their mass, if you talk of the mass, so mass of proton was greater than the mass of electron, which was about 1,000 times. It was greater than it by 1,000 times. Then about the J.J. Thomson's model. So Orosmith, can you tell me what was the J.J. Thomson's model? And what did it explain? What did the J.J. Thomson's model explain?
Plum pudding.
Sir,
It
it is
was
also
the
called plum pudding.
it was also called as the plum pudding model. So on what basis was it designed? What factors were considered during the design of the plum pudding model?
So he told that the pudding was like the positive electrons and the negative electrons were like the dry fruits in the pudding.
Okay, the negative electrons, they were like that. But what was the basis of making this? On what basis he could say
He
that the
told that
atom
the
is
positive electrons would hold on to the negative electrons.
okay? Positive electrons will hold on to the
The positive
negative
charge holds on to the negative charge.
okay, positive charge holds on to the negative charge. So was it not based on the neutrality of the atom?
Yes, so he also told that the positive, uh, the positive charges cancel the negative charges, so they're neutral.
Yeah. So basically, the Goldstein, J.J. Thomson's model, it was mainly based on the neutrality of the atom. Okay. That since the atom overall is neutral, so therefore it must contain all the protons and electrons. So hence, it the structures thought of by J.J. Thomson was that it's just like a plum pudding, where The atom is overall spherical in shape. Atom is overall positive charge and negative charges are embedded in them. Okay. Edge of the scene can be like what I thought that the atom in the atom we saw that the protons are positively charged. Okay, and electrons are negatively charged. So therefore, inside the atom, what should happen? That protons should occupy the major space since they are positively charged and they are heavy. So they should occupy a greater space, but the electrons should occupy a lesser space. Okay, so that was his thought that on the basis of this he gave the plum pudding model, right? Hmm? Okay. Okay. That's good. Okay. Hmm. Jump, jump, keep on. So understood the J.J. Thomson's plum pudding model? So after this was the alpha particle scattering experiment. So Neha, who carried out the alpha particle scattering experiment?
Sir,
Yeah, who carried out alpha particle scattering experiment?
Rutherford, sir.
Rutherford. So what was the alpha particle? What is an alpha particle?
The helium particle.
The helium nucleus is also called as the alpha particle. Okay, what was the mass of alpha particle? You need to remember these two things, mass of alpha particle and charge of alpha particle.
Sir,
Okay, who
4
will?
AMU.
4 AMU, very good. So who told this answer? Siddharth?
Sir,
Or
Prince.
Okay. So mass was 4 AMU. And what was the charge of the alpha particle?
Sir, positive 2.
Positive 2. It has a charge of plus 2. Okay, this is what is your alpha particle. Then which substance was used for scattering? Or Smith, which substance was used for
Sir.
scattering?
Gold foil.
Gold foil, very good. So there he used the gold foil for scattering. Okay. And what substance was used as a screen? For the screen. Yeah, what substance was used as a screen? That was a zinc sulfide screen. This was a zinc sulfide screen. Okay, so when any alpha particle comes and strikes the zinc sulfide screen, it produces scintillations on this screen. Scintillations means small dots are produced over there on the zinc sulfide screen. Okay, so some scintillation means some types of small sparks. They are produced on the zinc sulfide. It glows. You can say that the zinc sulfide screen, it glows if it receives any of the alpha particle. Okay. A similar thing happens. A similar thing happens when in the olden TVs, right now you have LEDs, which are your light emitting diodes. So right now you have LEDs, but just before that, around a decade before that, around a decade before that, you had some TVs like this. This was the front of the TV, and you might have seen some TVs like this. Okay, so they had some the screen had zinc sulfide or phosphorus. Okay, and some beam of electrons came and strike over here on this. So they come and strike on this, which produces glow, and a controlled way, their controlled way of where they should produce the glow can produce proper images. Okay, so that was the technique which was utilized over here in the zinc sulfide screen. So here was the source of the alpha particle. So from the source of the alpha particle, the scattering was done through the gold foil and then it was removed. So what were the observations of the alpha particle scattering experiment? And till I am asking someone, all of you will write down the observations of the alpha particle scattering experiment. You must write down without looking here and there, and all your cameras should be on. So you should write down the observations of the alpha particle scattering experiment. Okay. And the person whom I am asking, that person will answer. The other people will write. Rikshit? Rikshit?
Yes, sir.
Okay. So what were the observations of the alpha particle experiment?
Sir, the observations of the alpha particle experiments were that sir, the alpha particles, most of them passed through it the gold foil completely, but then some were deflected like by 180, like out of every 12,000 particles,
Mhm.
at least one would rebound, and some would deflect, like a slight deflect.
Okay. So that was a very good answer. Rikshit has given a very good answer for all the observation. The same thing I would also hear from someone else also. And Aman will do. Yeah, Aman, what were the observations of the alpha particle scattering experiment?
Sir, some rays went through the gold foil. Some
Mhm.
rays slightly bounced. Some rays bounced off. Some
No,
rays,
okay. Some of them bounced off. Okay. Do you say
some
bounced off or deviated?
sir, some rays deviated. Some
Mhm.
rays slightly changed directions.
Okay. See, a few of the alpha particles, they were bounced back, and some of the alpha particles, they deviated by small angles. So, Abhinav, can you explain me the conclusions? What were the conclusions of this experiment?
Sir.
Can you explain me the conclusions of the alpha particle scattering experiment? Like, see, suppose what I want to know, uh, I think I asked Abhinav.
Yes,
Abhinav, I
sir.
asked. Okay. So, like the first observation was that most of the alpha particles went straight. Okay. So, what did we conclude from it? What decision we arrive at? If most of the alpha particles passed straight, so what was the conclusion drawn out of it?
Mm.
Think of it. Okay.
Most
So,
of
you
them
know,
penetrated.
Most of the space inside the atom is empty.
okay, most of the space inside the atom is empty. This is correct one. So, since most of the alpha particles they passed straight, since most of the alpha particles passed straight, so it means that the maximum space inside the atom is empty. Okay, so your first conclusion that was drawn out of it is that most of the space inside the atom is empty. Most of space inside the atom is empty. Okay, so this is one of the conclusions. Then, what was the second conclusion that was drawn?
Sir,
Can
Hmm.
Sir, all the positive charge and the mass is in the center.
Yeah, all the positive charge and mass of the atom is concentrated in a very small volume. Okay? It is not occupying a bigger volume. So here, almost all the mass, you can say, all the mass and positive charge is confined to a small volume. A small volume. Now the third one. What was the third conclusion?
Sir, electron revolve around nuclei.
Okay, so how did we conclude this that the electrons revolve around the nuclei? How do we find out that the electrons revolve around the nuclei? See, electrons revolve around the nuclei. It was not a result of the alpha particles getting exploded. It was not a conclusion drawn out. Okay, so that we will study about the electrons revolve around the nucleus in the nuclear model, where the Rutherford gives his nuclear model. So there he tells that the electrons revolve around the nucleus. Okay, here our first conclusion was that most of the space inside the atom is empty, which we obtained from the first observation. Okay, then second conclusion we obtained from the that there is a center of positive charge. You can say like this. Your second point, you can say there is a center of positive charge inside the atom. That means all the positive charge is confined in a very small volume. It is not that positive and negative charges are mixed up together. They are not mixed up. Had they been mixed up, so the alpha particles would not have deviated by small angles. The alpha particles deviated by small angles. It means that there is a center of positive charge. Okay, and that center of positive charge, it occupies a very small volume. So you can say the second statement something like this, that all the mass and positive charge, the second point was all the mass and positive charge, all the mass and positive charge was confined or lies at the center, lies at the center. Okay. So it's not that the positive and negative charges they are mixed up. Like J.J. Thomson said that the positive and negative charges they are mixed up. Okay. So it's not like that that the positive and negative charges are mixed up. They are not mixed up. The positive charges they are separate. Okay. Now third point that he concluded that the center of the nucleus, center of atom, also he called it as the nucleus, is heavy and occupies very small volume. So this was the third point he concluded. Occupies a small volume as compared with that of, it occupies a small volume as compared with that of atom. Okay, so these were the three conclusions. Now I'll ask about the nuclear model of atom. So Aman, can you tell the nuclear model of atom? Yeah, Aman, can you tell the nuclear model of atom? Yeah, Aman,
Sir, I don't know.
don't know. So you should have revised this chapter. We have done this chapter. Okay. So from the next
Sir,
time you
is
should
it like
have.
the protons and neutrons in the middle and then the electrons revolving around them
See,
in
what is
like
that?
an oval
See,
shape?
the problem is that we know everything. Okay. But that everything is not put in a proper way. That makes a hodgepodge. Okay. Suppose if you are given in a dinner, you are given that gulab jamuns, you are given everything. You are given three types of vegetables, pulses, everything you are given, but everything is mixed up. So that should not be the same. You know everything, just put it together in a proper way. You just have to decorate that in a proper way. Like, okay, Aman? So that is why I'm revising. I want these things to be put up in a proper way. I want you people to write the observations in a proper way. I want you people to know that there are three observations. You can put up all the observations just in 3 points. Okay. And what are those distinct 3 points? How you are concluding those points? How you are obtaining the conclusions from those of the observations? Okay. So Neha, can you tell the nuclear model? Explain the nuclear model. Yeah, Neha. I want you people to put up all the points together. How the things are flowing. And that is what will bring you marks in the exam. Even if you know everything, but if you do not put them properly together, so that will not bring about the marks, or you will not be able to score them.
Sir,
Yeah, Neha. Yes.
sir,
Yes.
this model is about the gold foil and the alpha rays passing through it.
Hmm. So in the nuclear model of atom, how does Rutherford describe the atom?
So can I tell?
That they have spaces of it.
Okay. So the first point you can include that most of space inside the atom is empty. And he was also able to determine the size of the nucleus by the impact parameter, by how many alpha rays are deviated. So he was able to also estimate the size, not compute, he was able to estimate the size of the nucleus. Okay. So this is the first point, most of the space inside the atom is empty. Then the second point, what he put forwards,
That they are charged particles in it.
there are charged particles in it, but that is not a proper point again. Siddharth, can you give me the second point? Yes, Siddharth, can you give me the second point?
The electrons revolve around the
No,
nucleus.
the electrons was the third point. Electrons revolve around the nucleus. So before that, he defines the nucleus. So
Nuclear
before that,
positive charge and most of the mass is present in the nucleus.
yeah. So this was the second point, that most of the mass, most of the mass and positive charge, most of the mass and positive charge was confined to a small volume, to a small volume called nucleus. Small, confined within a small volume called nucleus. Okay. So this was the second point. Then Aman, are you there?
Yes, sir.
Aman? Okay. So do you remember the third point? What could be the third point of his model? Okay.
No, sir.
So, no, okay, fine. So, just as a hint, it was just told by Siddharth. Siddharth was also telling that point, and I made him to stop that. So, do you remember? He was just telling me the third point, and I told him, no, this is not the, this is the third point. You have to tell the second point. Okay, let's say Prince.
Yes, sir.
Okay,
Sir,
can you tell?
size of the nuclei is very small compared to atom size of atom.
Okay, that is we have concluded in the second point. Second point, says the same thing. Most of the mass and positive charge is confined within a small volume called nucleus. Okay. So third point, Orosmith,
Yes, sir.
what was the third point? See, this is how you have to put your answer. Harini,
Yes, sir.
okay, what was the third point about the nuclear model?
Uh, s- um, the positive charges were located in the center.
That we have done. The positive charges are located in the center.
The size of a nucleus is very small.
That also concluded small volume.
The electrons revolve around the nucleus in
Yeah,
circular.
the third one was that electrons revolve around the nucleus in circular orbits. Electrons revolve around nucleus in circular orbits, just like planets revolve around the sun. So this was also added, just like planets revolve around the sun. The way planets are revolving around the sun, in the same way, the electrons are also revolving around the nucleus. Okay, but there were certain differences or certain drawbacks which the nuclear model or the Rutherford's model of the atom it holds. So we will discuss each of the drawbacks. What were the drawbacks that were taken out of this? So Rikshit, I think let's see who will answer. Who has not answered? Orosmith. Orosmith has not answered any question. Okay, so just answered one small question, Orosmith. Okay, so Orosmith, what were the drawbacks of the nuclear model? Drawbacks, what do you mean by the drawbacks? Drawbacks means what were the things that the nuclear model could not explain? Like it was all correct with his experiment, whatever experiment he performed, the experiment was performed as the alpha particle scattering experiment. So the results they were very good with the alpha particle scattering experiment.
Sir, it failed to explain the stability of the atom.
Okay, so how did it fail to explain stability of the atom? So I'm noting down that was your correct answer, that it failed to explain stability. So how did it fail to explain stability?
Sir, can I?
So electrons will get attracted to the nucleus and finally they will.
So why will they get attracted towards the nucleus? Why not the planets are getting attracted towards the sun? The problem was this, why the planets are not getting attracted? Yeah, Siddharth, I think Siddharth had raised the hands. Yeah, Siddharth. So why it failed to explain the
Sir,
stability? What?
because while revolving around nucleus, it is considered as acceleration. So,
Hmm.
as it has a charge, it will lose its energy,
Hmm.
and further getting close to the nucleus. And
Okay. Okay. Quite correct. You are quite correct. So why does it not happen with the planets? Harini, why this phenomena not happen with the planets? Why it happens only with the charges? Why it was expected that the electrons will release energy and they will radiate energy? Anyone who can tell?
No, it does not happen with planets because of centrifugal force.
So the centrifugal force is same here also. Like over there, the planets are attracted towards the sun by the gravitational force. The only difference is that the forces were different. See, there were points of difference between the planet's motion and the motion of electrons. The difference is that the planets are not charged objects. Planets do not carry any charge. So planets are uncharged objects, whereas electrons are charged objects. Okay? In the case of the planets revolving around the sun, the centripetal force is provided by the gravitational forces between the planets and the sun. Whereas for the electrons, the force is provided by the electrostatic forces. So the two, they are entirely different. They are not the same thing. One is a movement of charge, the other one is a movement of planets, which is neutral. Okay. Also, the next thing that was expected, that since electrons are revolving in a circle and movement in a circle is an accelerated motion. If any object is moving in a circle, so we call that to be an accelerated motion. We have studied that in circular motion, right? If an object moves in a circle, so there is a change of velocity. At every point, the velocity is changing. The speed is not changing, but the velocity is changing at every point of time. And hence, if an object moves in a circle, if a charged particle or electron moves in a circular path, so that means it is accelerating. Okay. And if any charged particle accelerate, now listen, this you will learn everywhere. If you have an accelerated charge, so it radiates energy. So this was a law of physics, that an accelerated charge radiates energy. Right? If any charge gets accelerated, so it radiates energy. And hence the electron will radiate energy. Radiate means lose out energy. Therefore, ultimately, it will fall into the nucleus. So hence, the nuclear model of the atom, it could not explain the stability of the atom. If atom is like this, like whatever it was described by the nuclear model, so how it is stable? Why the electrons are not moving into the nucleus? Okay. However, he said that they were similar to the planets, but they cannot be similar to the planets. There are quite differences between them. Okay. So I hope you have understood the nuclear model. If I ask you any of the question up to the nuclear model, so I expect that everyone will be able to answer that. Okay. So everyone will be able to answer. Aman? Aman?
Yes, sir.
Okay, now can you answer about the nuclear model of the atom? These are the points. What was the nuclear model of the atom? That's given. What were its drawbacks? So that's also given.
Yes, sir.
Okay. So after this, this problem that the stability of the atom was not explained. So this was later on explained by Niels Bohr. And see how the Niels Bohr explained this. It's not only Niels Bohr, he also performed a number of experiments. There were other people also who were performing a number of experiments, and those were generally the spectrum of hydrogen. So it was the spectrum of hydrogen atom which was observed, and after that Niels Bohr put forward his theory. Okay, so not only the Rutherford, so after Rutherford, whatever everyone has said, so everyone had performed some of the experiments, and then only the person said, yes, it is like this. That is why it was accepted. So Niels Bohr, he studied about the spectrum of hydrogen, and he gives his theory of fixed orbitals, fixed orbits. Right? So according to Niels Bohr, the in a hydrogen atom or in any atom, okay, so fixed orbits, if you observe about the fixed orbits, so what were the points put forward by the Niels Bohr? How could he overcome? So you do not have to go into the much depth, what he observed, whatever he did, just a little bit of the Bohr's theory is given to you. Okay, and just in 2 points you will be explaining. So I'm giving you just 1 minute. Think of the things that this model explained.
कुछ नहीं मिला तो हमारी परवरिश पे हमारे तो खुद के मेहमानों से लोग परवरिश दिखाना केकर का चुरा ले लो हमारे काफी लगे
Okay, so I think now someone can answer this. Who can answer? Just raise your hands if anyone can answer. Raise your hands if anyone can answer the Bohr's theory. Can explain me the Bohr's theory. There are 2 points in the Bohr theory that need to be explained. So who will explain this? Okay, so no one is raising hands. So I need to ask now individually. Okay. So Prince will tell. Prince?
Yes, sir. Uh, uh, Electrons is discrete orbits or
Electrons, not the electrons are discrete orbits. Electrons are not discrete orbits, but electrons revolve in discrete orbits.
yes, sir.
Okay. So, and not only discrete, you say 2 words, there are 2 words. Okay. Those words we say that electrons revolve in discrete stable orbits.
Yes, sir. Or shells.
Yeah, stable orbits or shells. Very good. So what was the second point?
Uh, they do not radiate energy.
Okay. So they do not radiate energy. Do not radiate energy.
When in their orbits.
Yeah. When in their orbits. When they are in their orbits, they do not radiate energy. Fine. So this was about the Niels Bohr theory. So what were the shells that were discovered? What okay, what names were given to the shells? Abhinav will tell. Abhinav, what names were given?
A, L, and M, right?
Hmm. The names were given as K, L, M, N. Can I also give them as numbers? Aman, can I also give them numbers?
Yes, sir.
Okay. So what number will be given to the K shell?
1.
1. This is 2, 3, 4, 5. Now out of these, which one is the innermost shell?
K.
K is the innermost shell. Okay. Prince, how many electrons are required to fill the K shell?
Sir, 2.
All right. So there are two electrons are required for filling out the K shell. Then how many electrons are required for filling out the L shell?
Sir, 8.
8. Very good. So 8 electrons are required to fill the 8 L shell. Abhinav, how many electrons are required to fill the M shell?
Sir, is it 4 or 8?
Yeah, Abhinav, how many electrons are required to fill the M shell?
Sir, I guess it's 8, right?
Okay. Uh, Siddharth, is this correct? That M shell should have 8 electrons.
Yes, sir.
Okay. See, the M shell does not have the capacity of 8 shells. It has
Sir,
the
it has
capacity of
18.
18. It has the capacity of 18 electrons. And the capacity of the electrons is given by the formula 2n squared. If you forget, this is the formula 2n squared, where n stands, or n is the number of shell, the number of that shell. That is n. So Neha, what would be the capacity of n shell?
Sir, 32.
32. Very good. Okay. So n has the capacity of 32. And how
Sir,
it was? Yes.
is there only one drawback for nuclear model of atom?
No, there were two drawbacks. 2 to 3 drawbacks you can think of. Like here we discussed this, it failed to explain stability of the atom. You can say the movement of electrons, and movement of planets are different. Movement of planets, they are different. They are not the same. Okay. But the major drawback, which we consider, the major drawback was this one. It failed to explain the stability of the atom. So if you learn this way, then your answers would carry weightage. You will get your marks. Okay. So, Smith, what will be the number of electrons in the fifth shell? If there is a fifth shell, so how many electrons shall be there in the fifth shell?
Fifty, sir.
54? Are you
50.
getting 50? Okay, so this has the capacity 50. And sixth one, if there are 6 cells, then how many electrons will be there? Okay, who will tell? Aman, how many electrons will be there in the sixth shell?
Sir, is it 72?
Yeah. So now you are correct. This will have a 72. What if there is a seventh shell? So how many electrons can be there?
Sir, is it
Sir,
90?
98.
98.
98. Okay. Now there is a small question and let's see who can answer from all of this what we have studied. So there is an atom. Okay. An atom has four electrons in fourth shell. Okay. So you have to tell me what is the total number of electrons that it has. Or if you are getting confused with the fourth shell, let me give it as the third shell only. So an atom has 3 electrons in the third shell. So what will be the total number of electrons? You have to give me total number of electrons. You have to give me the number of protons. Okay. You have to give me the atomic number. And at the last, you have to identify the element. Okay, so no answers? No one is able to answer these questions?
So 1 second. So is the number of protons and electrons 14?
Okay. So let's check. Yes, the answer is 14. The
Silicon,
number of electrons is 14. The number of protons is also 14. And which element is this?
silicon, Si.
Yeah, this is silicon. Atomic number is 14 and the element is silicon. Okay. Bye everyone. See you again tomorrow and I hope you will get this revised. I'm sending this in the group. You can revise this and then join the next class. Okay. Bye everyone. Good night. See you again.